It is 10:21 p.m. for Sunday, November 16th. It should be vacation. Now, I'm tired of going to school. I have 1 week left, but I have a Japanese project, which I'm not actually too pressed about. I'm just really bad. We just have to create a 6-minute dialogue between two people about planning a trip to Japan in Japanese using the grammar that we've come up with or that we've learned, and I am just really bad at coming up with things. But once I do, and once I get it translated, it should only take me to Wednesday probably, and then get it done. The thing that I am worried about is I have the ComSci project about the action potential of nerves. And it's really frustrating because I am a computer science person. I love coding. And this class has been trying to do a little bit more, bringing in different subjects within computer science, like biology. So far, pretty much only biology, but I guess neuroscience right now that we're doing, the Hodgkin-Huxley model, and we're using. It's really frustrating because all the things that we've learned how to do are really simple in my mind. And I have the differential equations needed, but there are a couple of other components specifically to this lab that we have not been told how to do. We needed to keep track on how many the ion concentration outside the axiom versus inside the axiom, but we're never told, well, the equation for that is actually just the current, because current is just the flow of ions. And I figured that out, but the current is so high that you actually needed to multiply by the time step, which in now retrospect makes sense, but it didn't in that moment, and we just weren't told, and it took me 2 days to figure that out. But then I also have this problem of just it not looking quite right for what it is, and there's some things that are just that aren't just quite right that I know a general fix for. Or there's when the sodium channels close, if you ever looked at a Hodgkin-Huxley model, it goes down and there's a section that is the hyperpolarization. And I'm not expecting anybody who's listening to this to actually understand it because I'm kind of venting right now, but the hyperpolarization, I understand why it happens, but I have not been given the point in time where I should be shutting off those sodium channels. I have made it so that when the voltage starts decreasing after that, then I can close it and then close that sodium channel and just have the sodium leakage channel be open, and that seems to work. But the problem I am having is that just doesn't seem right, and I haven't been told that. It's just we have not been given information on how this model works, how it's supposed to work beyond some vague guidance. But it's also I am not a neuroscientist. I don't understand these intrinsically. We have had one class to understand neuroscience. And it was a very interesting class. It's probably one of the best classes I've had this semester in my computer science class because it was very interesting. And the teacher who taught it was a biology professor here, and he was very entertaining and very good at getting the point across because we are all not neuroscientists. We're all computationalists. But now we have to apply those principles that we just learned in one class into this model and apply more things and come up with more things that we haven't learned. And it's really, really frustrating because I'm trying to ask him a question. I'm hey, I know why this happens, but I know it's not supposed to happen. But could you help me out? And he's email me later. So I emailed him later, and he's hey, this is I don't even remember what question it was, but this is not a good I don't know how to answer this. And I'm oh, come on, I just need to know why this one thing isn't working, then I'm pretty sure I'm done with the code. And it's not the fact that having me figured out is going to be this massive learning experience. It's just that it's going to be, I'm telling you, the reason that it's tapering off and kind of curving instead of being a flat up and then a flat down is inherently just the equations that you gave us. As the voltage gets to that point, it will taper off because it will never reach the 50 millivolts that we set as its target, because the leakage is always bringing it down to negative 54.4 millivolts. And so we set it too close to 50, then it will taper off. That's just what it does. And like if I set it to 1 millivolt higher, it doesn't taper off anymore. And so it's just frustrating, because I understand completely why it would happen in a neuroscience context. Like, that's just what the equations do. That's what biology does. Eventually, the pull of the ions, like you open the channels too much that there's not enough ions to flow through anymore, and it starts tapering off, and then it'll slowly go back down. That's what's happening, and it's really, really, really frustrating, because I know he's not going to just say, oh, you're this part is wrong, you need to figure it out. He's just going to be like, he'll start asking questions and be like, that's not quite right, I need you to think about it more. I'm like, I don't want to think about it more. I have too many things to go on in this weekend, and I just need to make it through. I'll have to write another 30 freaking page report on this, but I just need to get this code done, and it's so frustrating. I thought this class was going to be really cool. It is so frustrating because I'm sick of this theoretical computer science BS. I just want to code. The coding is so fun, but when each project consists of 10% coding and 9% write-up, it's so frustrating. And yeah, I'm just kind of done. I'm going to go back to my room. I'm going to upload. I have not posted in a week, even though I have a backlog of videos, just because I felt so busy figuring things out. But we'll get there. So I just need to post everything and do other work, and I will be okay. I just have 5 more days of classes, 2 classes per day. I should be able to make it.